city smoking switches. Fuck it, I'm high. Fuck it, I'm fly. Fuck all these niggas living a lie. I'm up in the sky. Ain't coming down unless I'm tipping niggas is lame.
Alright, moving on to the next topic. We have something called error bounds. Because yes, we and the integrals are not, we and the approximations are not perfect. So error bounds basically measure how accurate or inaccurate your approximations are. So error for the trapezoidal approximation, and these are just formulas, so you'll have to become familiar with these. This is going to be less than or equal to the following. So k2, and I'll explain what k2 is, b minus a to the third over, then we have a 12n to the third. And then I'll write down the one for our midpoint approximation, 2, n, and then that's an n, sorry. This thing here is an n. Less than or equal to, and then we have k2 again, and then b minus a to the third over, and now we have a 24 down here. So that's the important distinction here. And also, I'm sorry, this n to the, that should be a 2, not a 3. Getting my 2's and 3's mixed up. Okay, so n, again, that's the number of subintervals that you have. And then k2, this is what is important to explain. So k2 is, formally, it's written like this. And that doesn't really help much for the explanation. But basically, also this. And I'll explain this as well. So for all x on the interval, basically this just means that k2 is your max value of the second derivative, okay, on this interval of second derivative. So, yeah. So let's say you have a graph for some reason, and your second derivative, I'm just going to make one up to make it simple, right? So let's say your second derivative is, I don't know, maybe like x squared, okay? Maybe that's what it turns out to be for some reason. And then we'll have our normal like x squared graph, and our interval from a to b, let's say it's 1 to 2, okay? So here's 1 and here's 2. So on this interval here, what is our maximum value? It's going to be 4, right? So f prime of 2 equals 2 squared equals 4. And you take the absolute value, and that's pretty important, because what if, here, I'll move on to the next slide. Just keep this in mind so far. Let's say we have our second derivative. Let's say our second derivative instead were negative x squared, okay? And we're evaluating from 1 to 2 again. And so this just points down, basically. Same concept. So here's our 1, and here's our 2. And at 1, we know that this is going to be, well, okay. So this will be negative 1. And at 2, this is going to be a negative 4. So maximum doesn't mean the maximum number, like as in the most positive. It just means the magnitude. That disregards the negative. So our biggest magnitude would still be the negative 4 here. Or, well, the 4. So, because we're taking the absolute value anyways, okay? So this is going to turn out to be positive 4 anyways, okay? So, now we'll move on to a different approximation. So we already did trapezoidal and midpoint. Now, something called Simpsons Rule. And this isn't like Homer Simpson. I don't know. This is some other like mathematician guy. So, yeah. All right. So this is kind of a combination of trapezoidal and midpoint. So naturally, a combination of things, that's going to be a little bit more complicated, but not too bad. So the formula for this is Sn equals 1/3 delta x, our famous delta x, and then this is the important part. So we have our y naught, and this is this is the same thing as our function evaluated at x naught, remember? And then we have 4y1 plus 2y2 plus, and then you just keep going until at the end we're going to have our yn and just a 1 in front, and then you kind of go backwards. It's like symmetrical in both ways. in that then we have y minus n minus 1, and then here is a 2y n minus 2. So basically from either side, the pattern, so here's our pattern of the brackets, is going to be 1, and then a 4, and then a 2, and then however many you need. And then from the right side, you need a 1, and then a 4, and then a 2, and however many you need in the middle to fill in. So technically this could, like, if you only had, I don't know, what, 2, we can't have 2 terms. That's, well, you can have 2 terms. Then you would just get rid of the 4s and 2s. But let's say you were to have 4 terms or something. Then you'll have your y naught, and then 4y1 plus 2y2 plus 4y3 and 1 y4. Okay, so that's what it would be if your n were 4. But that's the general concept. Okay, and then error. So the error formula for Simpsons Rule, or for Simpsons approximation, I guess you'd call it. So Sn is going to be the following. So K4 now, b minus a to the 5th, all over, now we have a 180 down here, and an n to the 4th. Okay, so the K4, because K2 meant we were dealing with the second derivative, K4 is actually going to be your maximum value of the 4th derivative on the interval from x goes from a to b. Okay, so this is basically max magnitude. I'll just call it magnitude because that just means it disregards the sign. Max magnitude of your 4th derivative. Okay? Alright, so now I'm going to do an example for this error bound. This is going to come up on your homework. So find error bound for, I guess they call it in S6. So this is equal to our Sn, right? So n equals 6. That's what we can deduce from the problem. And then here's the integral they give us. 1 to 3 of 1 over x dx. Okay? So what we have, so here's our formula again. It's always good to write down the general formula, even without, like, just with the variables and not the numbers plugged in, because then you get used to writing it and then it kind of becomes a standard process, and you become familiar with it. So that's always good. And then we have 180 n to the 4th. Okay, so we know our n. That's good. We know b and a. That's going to be 3 minus 1, which equals 2, right? What we don't know is K4. And this is typically going to be the problem. You don't know the K part, and yeah, we don't know what that is. So we do have to find, that's like, I like to write this as f max 4th derivative, because that just reminds me this is the maximum value or magnitude of the 4th derivative, okay, from a to b, which is 1 to 3. So what we have is, let's find the 4th derivative. So f of x equals 1 over x is x to the negative 1. So then the first derivative is going to be negative x to the negative 2. And then the second derivative is positive 2, x to the minus 3. Okay, we're going to be, oh, no, that's not a 4. I'm trying to skip steps here. Okay, so we have the third derivative is going to be negative 6, x to the negative 4. And finally, the 4th derivative is a positive 24, x to the negative 5th. Okay, so now that we have the 4th derivative, what are we supposed to do? So basically, because we can see that this is an exponentially decaying graph, because it's 1 over x to the 5th, so it's going to look something like that, right? Something like that, yeah. And then we're evaluating from the integral from 1 to 3, so we can kind of see the maximum value is going to occur at 1, right? And then you can always check and plug in points and stuff, but I'm just going to say the maximum value occurs at 1, and that's going to be 24, right? Okay, so now we have our K4. So our error of S6 is less than or equal to 24 times, and we found b minus a equals 2 to the 5th over 180, and then we have a 6 for our end spot, and to the 4th. Okay, so this actually turns out to be error S6 is less than or equal to 0.0033. And that's what I got when I plugged into my scientific calculator. I'm pretty sure that's right. I did it twice, so we'll see. But yeah, so this is our final answer. Okay, and that is our error bound. And bound just means like what it can't exceed. So it's always going to be less than or equal to this number. Okay, so that wraps it up for section 8.8. And I will talk to you later if you watch the homework videos.
You know I'm clean, then a bitch, you know I'm clean, then you know I'm clean, then a bitch, you know I'm clean, then you know I'm clean,